Okay, so I'm going to work through the highlighted problems. So we are using implicit differentiation in number 4 to find dy over dx. So my first step is going to be stating that I am differentiating with respect to x for each term here. Okay, on the left-hand side, the 3 is going to hang out, and then we have to use product rule in order to find the derivative of x times y squared. So that will be x times, thinking chain rule, 2y, which is now y to the first power, times dy over dx. Okay, plus the second factor times the derivative of the first, which would just be 1. Derivative of x with respect to x is 1, and derivative of 5 with respect to x would be 0. So now we're just trying to get dy over dx by itself. I'm going to distribute the 3 into so that I can get rid of the brackets. So I'll have 6xy times dy over dx plus 3y squared equals to 1. And now thinking about moving everything away from the dy over dx, I'll subtract by 3y squared on each side. And then divide by 6xy. And I believe that's it. Okay, so number 5, same first step, stating that I'm differentiating with respect to x. I'm going to rewrite the square root of x as x to the 1/2 power. Pulling the 2 out from the x squared. Okay, so on the left-hand side, to find the derivative, we're going to need to use product rule. So first factor times the derivative of the second factor would be 1/2 x to the negative 1/2. And then it would be times derivative of x with respect to x, which is just 1, so we don't need to write anything. Plus x to the 1/2 times the derivative of y squared. So thinking chain rule, that would be 2y to the first power, then times the derivative of y with respect to x, which is dy over dx. Okay, on the right-hand side, derivative of x squared, and then times 2 would be 4x, and the derivative of 1 is 0. So again, we are trying to move everything away from the dy over dx. First thing though, I'm going to rewrite that first product and get rid of the negative exponent. So I can write that as y squared over 2 times x to the 1/2, or if you want to write it as the square root of x, it's up to you. And then I'm just changing the order of the factors, which I'm allowed to do by the commutative property of multiplication. So now I'm going to subtract y squared over 2x to the 1/2 from each side. And then to finish getting dy over dx by itself, I'll divide by 2x to the 1/2 times y on each side of the equation. And we're almost done, but we do want to get rid of that complex fraction. So I'm going to multiply by 2x to the 1/2 over itself in order to get rid of that complex fraction that's in the numerator. And thinking about distributing to each term that's in the numerator, we would have 8x to the 3/2 when we add the exponents together, minus y squared over, that'll be 2x to the first power because 1/2 plus 1/2, oh, it would be 4x, right? 1/2 plus 1/2 is 1, so 4xy. Okay? Just trying to find the next one. I highlighted them all. Oh, there we go, number 23. Okay, so the way that 23 is written right now, we have a product. So we have x times 1 minus cotangent. So I need to use product rule. First factor, and then times the derivative of the second factor. Well, the derivative of 1 is 0. The derivative of cotangent is negative cosecant squared. But then because that's negative cotangent, it'll be the opposite. So the derivative of 1 minus cotangent will actually be positive cosecant squared of x. And then plus that second factor times the derivative of the first. And we don't really need that grouping symbol. I'm not sure how the order that I have the terms in my worked out solutions that I posted, but that would be our derivative. Okay, and then for number 30, we again have a product. So thinking product rule, first factor times the derivative of the second factor would be negative cosecant cotangent plus the second factor times the derivative of the first, which would be negative cosecant squared. And then just simplifying, that's going to be negative cotangent squared times cosecant minus cosecant cubed.